Hello again. While this is still up here from my previous video, which was quite a bit for one video. That was the longest video I've ever made. But it really just went through a couple of processes, but I did a lot of explanation, so it took some time. Right? Just to remind you, I taught you how to do synthetic substitution to find a function value, and then also went into the fact that, okay, well, we can also use this process to do synthetic division, to divide a polynomial, and that can help us in factoring a higher degree polynomial completely. How else would you factor a cubic polynomial? Well, you can use grouping, right? Grouping is always the first strategy you should use when you're looking at a cubic in particular, polynomial. Check for grouping, right? See if you group the first two terms together and the next two terms. See if you end up with the same factors in the parentheses, the same expressions, I should say, in the parentheses. You don't in this case. You can't use grouping. So you have to have some alternate strategy, and this would be it. Okay? Now, I'm going to erase this and explain to you that the only possible rational roots, meaning, once again, we figured out that the factors of this guy were 2x plus 3, x plus 1, and x minus 2. This is the factored form, right? Well, what that means is that the roots of the polynomial are negative 3 over 2, negative 1, and positive 2. Those are the roots. Those are the x-intercepts for this polynomial. So then we can graph this polynomial kind of accurately. We would need a computer to really graph it very accurately, but we would at least be able to show the intercepts. All right? But these are the roots of the polynomial. The only possible rational roots, rational numbers, are numbers that can be expressed as the ratio of two integers. The ratio of two integers. Negative 3 over 2, 1 over 1, 2 over 1, etc. Okay, these are rational numbers. The only candidates for rational roots of a polynomial, this is the rational root theorem. The only possible roots are factors of the last number divided by factors of the first coefficient. I should say coefficient. Factors of the last coefficient divided by factors of the first coefficient. Any combination of those. So, like, here are all the factors of 6. Forget the fact that it's negative, right? Here are all the factors of 2. So any combination of the factors of 6 divided by the factors of 2 are going to give us our candidates for rational roots of this polynomial. So if you were asked to factor this polynomial without being given anything, you were sort of given that the 2 was a root, right? So we could use synthetic division, or I kind of alluded to that, to be able to factor this. But if you were given nothing but a blank sheet and asked to find the roots, or asked to factor, you have to use some guessing and checking just to find your first root. Okay? To find your first root, you would just have to guess and check with a bunch of these until you found ones that are roots. Okay? How do you guess and check? Well, when is something a root? When do you know that something is going to be a root? When, if you plug it in for x, you get 0. Right? So, well, let's start by 1 over 1 is 1, right? 2 over 1 is 2. 3 over 1 is 3. Those are really easy numbers just to guess and check with, just to try to begin. So it's a little bit tedious, but almost in your head, plug in 1, or negative 1 for that matter, right? Plug in 2, or negative 2, and then plug in 3. So, come up with some systematic, efficient approach to this. I wouldn't try, well, this one doesn't have anything too weird, but 1/2, right? 1 over 2. 1/2 and negative 1/2. Those are possible roots. I wouldn't try that first. Okay, one of them is actually a root. We know, no, the 3 over 2, right? 3 over 2, negative 3 over 2. Those are also possible roots. And one of those was a root. But why would you try that? All you have to find is one rational root, and then use synthetic division to whittle this cubic down into a quadratic, and then factor, all right? So, for instance, we can try, well, we already did this, right? We already tried, like, 2 over 1 was 2, right? 1 was 1 a root? I think it might have been, right? Because x plus 1, I'm pretty sure, was a factor, right? Well, if x plus 1 was a factor, negative 1 would have been a root. Well, let's just kind of check on that. If we plug in negative 1, we don't have to use synthetic division, right? You could just plug in negative 1 everywhere and see if you get 0. But just to review, I will use synthetic substitution. Again, you bring down the first number, you multiply, you add, you multiply, you add, you multiply, and you add, and we get a remainder of 0, right? So just to remind you, that means that yes, negative 1 was a root. Again, you could have just plugged it in. Negative 1 to the third is negative 1, times 2 is negative 2. Negative 1 squared is 1. So now we have negative 2 and 1, so we're at negative 1 so far. When we plug it in here, we'll get positive 7. So now we have positive 6 minus 6 is 0. So if you plug in negative 1 up here, you get 0. If you use synthetic substitution, you get 0. Whichever way you want to do is fine. It doesn't matter. Okay? You can even use a calculator. I don't have it with me, but you can use a graphing calculator. Type this function into the y equals. Type this function in there carefully, and then check the table. Just read down the table until you find an x value that gives you a y value of 0. That means it's a root. I'm showing you the algebra. I'm showing you how to do this by hand. But you can use a graphing calculator. So that's kind of probably the fastest way to do it, right? Just typing this into y equals in order to check for a root. All right? Anyway, once again, once you find that one root, what do? Well, so I've gone over the rational root theorem. I can erase this, but I'd like to, can I write it out here? Will I have enough room? Yeah, I want to leave it up here just for one more second, all right? Because there's something else I want to say about that. Again, it's just to give you the candidates for the roots. That's why we knew to try negative 1. Why else would we know to try it? You don't always try negative, well, 1 and negative 1 actually always are possible candidates, right? You'll always have 1 as a factor of anything, right? But otherwise, you wouldn't know to try 2 or negative 2 necessarily unless you had this theorem. Right? But again, once we know one root, we can get the rest of them just by factoring. Just to remind you, that's the remainder. I'll write an r for now. This is the constant term. This is the linear term. And this is the quadratic term. You work backwards. This is how it always goes. Remainder, constant, meaning the number by itself. Linear, the number with an x. Quadratic, the number with an x squared. All right? So we have now 2x squared minus 1x minus 6. That's what's remaining. All right? We've essentially divided this cubic polynomial by x plus 1. We divided this cubic polynomial by the factor x plus 1, because a negative 1 went in there. And what we were left with was this. Now we can keep factoring with this and know our additional factors. 2x and x, and then it looks like we're going to have a, let's see, 6 and 1? No. 3 and 2? Yes. Right? 3 and 2 is going to work because now we'll have a 4x and a 3x, and somehow we can make the negative 1. I put in the signs at the very end. To make the negative 1, we need the positive 3 and the negative 4. All right, so now we have, and I'll throw in that x plus 1 at the end. Okay, why is it x plus 1, not x minus 1? Once again, the number you choose in here, that's sort of, that is the root, right? That's the solution, x equals negative 1. Where would that have come from? A factor that's the opposite sign, x plus 1, okay? It's confusing, but that's why I make this video, all right? So we know the 3 factors, and once again, we know the 3 roots. Negative 3 halves, positive 2, negative 1, okay? So the purpose of this additional video was to go over how we go about this problem from scratch, and that's the rational root theorem. Okay, we always just take factors of the last coefficient divided by factors of the first coefficient in order to figure out what the candidates are for the rational roots. Now, all of the possible rational roots. If you, on a test, I will ask you that. List all possible roots. So I do want to do that here. All possible roots. I don't know why I capitalized this. Sorry. It's going to bother me if I don't. All possible roots. 1 over 1. And the plus and minus. Have a good systematic approach to this also. 1 over 2, right? 1/2, plus or minus. 2 over 1, which is 2. 2 over 2. Well, 2 over 2 is 1. And that's already written, so we don't write it again. Don't write it again. 3 over 1 is 3. 3 over 2, that's not been written. It's 3 over 2. Am I off the screen yet? Nope, but I'm tripping over desks. 6 over 1, plus or minus 6. 6 over 2 is 3, that's already been written. So these are the possible rational roots. These 12 numbers. So you're really unlucky if you try, if not until your 10th or 11th try, do you get a number that's a root. We were very lucky. We guessed -1 and found that to be a root, okay? But again, that's why, generally speaking, guys, on tests and quizzes, I'm going to give you problems where the roots are some of the, what I'm saying is if I don't give you a root, because some problems I'll tell you, okay, x equals 3 is a root of this polynomial, find all the roots. All right, then you know to use 3 in synthetic division. But if I just give you the polynomial and say find all roots, you have to apply the rational root theorem, but you won't have to guess forever. If you do what I'm saying and you check over the more friendly roots first, you'll see on your first, second, or third try, you're going to get a number that's a root, okay? You're going to get, that 1 or -1 or 2 or maybe -3. One of those nice integers is usually going to be a root. Right? But again, check your calculator. If you type this into y equals and you just check the table feature, second graph is the table, you'll be able to see the x values. You'll see blatantly 2 and -1 as roots. So you can use either one. Right? The whole goal is to find the number that goes in the square. Okay? So, wow, this is taking quite a while, and that's good that I'm doing these videos, because this saves us a lot of class time, and you being very bored in class. Here's my handy-dandy note sheet. There's one more thing I wanted to do, but have a nice weekend.